So next is another one of our theorems. A couple chapters ago, we learned the intermediate value theorem, the IVT. The second big theorem in our course is called the extreme value theorem, or EVT. And again, this is what's known as an existence theorem. It doesn't tell us what actual values are, it just tells us whether certain values need to exist. And again, it's very important for us to pay attention to the hypothesis in that it must be continuous on a closed interval. So the only time we can actually use the EVT is if it is continuous on a closed interval. That doesn't mean that our conclusion isn't necessarily true. We're just saying that if f is continuous on a closed interval, our conclusion must be true anyways. So this is saying if f is continuous on a closed interval from a to b, then there must be an absolute max and there must be an absolute min on that interval. Again, it's not telling us what they are or where they are, just that they have to exist. So for example here, if I say that on the closed interval from a to b here, well, looking at this, it is continuous on that interval. So there has to be an absolute maximum, and it looks like it's right about here for this one. And it actually looks like my minimum occurs at each endpoint, and so I'd have two absolute minima. Now, if I happen to have a function that is discontinuous on a closed interval, or if I don't have it on a closed interval, it's on an open interval, that doesn't mean that there isn't an absolute max or min. It just means the EVT can't guarantee it because I can't use the extreme value theorem then.